Now, in this tutorial we're looking at section 6.4, which is about the quotient rule. Hey, we've had a look at the chain rule and the product rule already, so now we're into our last of our main big rules, which is the quotient rule. Okay, so we're saying this time that f of x is equal to g of x divided by h of x. Hey, if that's the case, then our derivative is equal to h of x times g dash of x minus g of x times h dash of x over h of x squared. Okay, or if we want to write it as y equals u over v, then dy dx equals v times du dx, take u times dv dx on v squared. Then what's really critical about this is we do actually need to make sure that we've got the order correct, okay, because of our takeaway here, because 3 take 2 is different to 2 take 3. So for the same reason, we need to make sure that we get this order right. Where it didn't matter with the product rule, it certainly matters with the quotient rule. Okay, so we'll have a look at our first worked example, okay, which is if f of x equals sine of 2x over x squared, find f dash of x. Okay, similarly with the product rule, setting out really makes these a lot better. So we say sine, g of x equals sine of 2x and h of x equals x squared. So g dash of x, okay, our constant comes out the front, so we get 2 cos of 2x and h dash of x is equal to 2x. Okay, so now we just need to put everything together. Okay, so go h of x, so that's x squared, so we'll go f dash of x equals our x squared times our g dash times 2 cos of 2x minus g of x, which is sine of 2x times h dash, which is 2x, all over our h of x squared. So our x squared squared. Okay, so that'll mean that f dash of x, we'll make it look a little bit nicer here, and so we've got 2x squared cos of 2x minus 2x sine of 2x over, okay, x to the 4. Okay, we can simplify that because we can get rid of and cancel out an x and say that we've got 2x cos of 2x minus 2 sine of 2x, okay, all over x cubed. If you really want to, you could take 2 out as a common factor, but I probably won't worry about doing that too much. Okay, so I'll keep moving on. Okay, so this time we have our function f of x equals cos of 3x over 2e to the x minus x, and we want to find the gradient when x equals 1. So again, we go g of x equals cos of 3x, okay, h of x equals 2ex minus x. Okay, so then our derivative of g dash of x equals minus 3 sine of 3x. Okay, for the first part, okay, and h dash of x is going to equal 2e to the x minus 1. Okay, this bit won't change. Okay, so now we've got to get everything organised. Okay, so we've got to start with our h of x times our g dash of x. Okay, so it's the opposite way that we do them this time. So f dash of x equals our 2e to the x minus x times minus 3 sine of 3x minus, okay, we're going to go this way this time, so 2e to the x minus 1 times cos of 3x over our h of x squared, our 2e to the x minus x squared. Okay, and we don't really need to do too much work here. Okay, you're not going to get too far anyway doing that. So I would probably more or less leave it where it is at that point, because it looks pretty messy and it's not going to stay much better. to be honest, you could probably bring this 3 out there, but it's not going to make too much difference. So we now want to find when the gradient is equal, find the gradient when x equals 0. So we say f dash of 0 equals 2e to the 0, take 0, times minus 3 sine of 3 times 0, minus 2e to the 0 minus 1 cos of 3 times 0 all over 2e to the 0 take 0 squared. Okay. We know sine of 0 is 0. Okay, so this part is all going to cancel out and be 0. Okay, which works out nicely. Okay, and then we've got here that we're going to be, that's going to be our 2 take 1 is 1. Okay, times 1 is 1, so we're taking away 1 again. Okay, over 2 take 0 squared, which is going to be 4. Okay, so we're going to get 2 minus a quarter. Okay, and that's the last word example we have for this section, so hopefully that's enough to get you through. As I said, the quotient rule is a bit trickier because we need to be very careful about the order, but again, if you set out well, then the problems generally just flow through and don't cause you too many issues, hopefully.